Cool. All right, as a one quick reminder, I think everyone here did, but it's full to attendance form. If you guys haven't already, but I think everyone here should have. All right, so today is lesson number 8, which is going to be all about NoSQL databases. This is like the last thing we'll learn today or new this semester. Our next 2 weeks will be move this chart away. Are going to be 2 project work days. So you guys can come in. We'll be in the other room next time, and actually in Hampton 1144. And so you can come in, ask questions about the project, work on it. We'll go through the demos a bit more detail there too, probably, and the requirements in more detail as well. But we'll kind of skim through them today so everyone has an idea what to work on. And this project will be due a week after the second workday. So I believe, I forget what it is exactly, but I think it's like the 13th or 14th or somewhere around there, basically, of November. It is the week before Thanksgiving, I believe, is when I put it on maybe. I don't remember the exact date, but it's somewhere between the 15th and 20th. I forget what Saturday that is. But if you need more time, let me know. I will be more than happy to give it to you. We want everyone to get the certificate, so it should be more like a soft deadline than a hard deadline, really. This is actual slides, my bad. Okay, we probably all familiar with this slide already. Obviously, office hours. We will be holding them the next 3 weeks, so please come by for either the working days or the office hours if you need help with their project. And it can get confusing, so please do stop by. Don't get discouraged. You all can do this, I'm pretty sure. Yeah, obviously this is Sam is on the other room today, so I'm teaching us today. So hopefully I'm doing a good job. We'll see. Yeah, and also as always, you have npm installed, VS Code open, slides, code downloaded. There is new code for this lesson in the lesson 8 branch on GitHub, so you may want to take a look at that or download that at your own pleasure. All right, quick review. So what is Vue? Good question, right? So Vue is a library that we use to modify HTML. We use Vue directives to do kind of a lot of actions with very little code on our side at least. And we can also make components that can repeat code or have more defined behavior that just act like a simple tag in our actual HTML. Here are the Vue directives. I'm pretty sure everyone should be pretty familiar with using them already, but vbind will bind attributes, including like props if you want to pass in props to components. VF displays things conditionally speaking to the page. VModel tracks input. VON will handle events, either custom or like blind clicks. And then V4 will repeat elements, or will repeat a HTML element for as many JavaScript elements as there are in an array. For example, like a list of some things, hint, hint, hint. Vue components. So Vue components are more specific, like single file components are kind of like a mini HTML page. Each component is going to have its own data, its own method, its own formatting. And we use events and props to kind of communicate data back and forth between the main view, or the parent component of the main view instance, and the child components. And then single file component is each component is a separate file now. We use npm to compile all these. And each file is going to have a templates section, a style sheet, your CSS, and at the very bottom in the middle there, your script section. And then finally, Vue Router, which is last week. So Vue Router is basically used to show different Vue components depending upon which URL you visit. And you can then navigate and pass data between these different views, as they're more generally called, using either HTML or JavaScript. However, you'll quickly learn the JavaScript way is a lot easier than the HTML way sometimes. So keep that in the back of your mind. Okay, any questions about JavaScript or Vue Router or Vue components or Vue in general? Cool. In which case, we'll jump into databases. So first things first, who here has ever heard of or used a database before of some sort? Maybe one. That's all right. So databases are basically, generally speaking, a way to store data in a central location. And databases make it very, very easy and actually meant for synchronizing this data across multiple users, multiple platforms. For example, Amazon will have a database of products they sell, YouTube with videos, or the New York Times with subscribers that subscribe to the New York Times. And for the longest time, the go-to language or the go-to structure for databases was like a table format using something called structured query language or SQL. And each table will have columns, which each column representing a field, and each row in the table would be one entry to the database. So for example, you might have a user database, a user table that had a column for the name, a column for an email, and a column for their password. Now, you wouldn't actually do this, but as an example, each row of that user table would be a singular user entry, have their full info, their name, username, ID, password, whatever you want to put in that database. However, a lot of data does not make so much sense to store in a table format like this, or it doesn't scale very well for web applications like we have now. Back in the old days, SQL worked really well when you had like one server and like one database in one data center in like one location. But now, with like the advent of the modern web, we have servers around the world doing simultaneous things with different users. And SQL can be very slow and hard to make sure that the databases are consistent across different geographical places. So to kind of fit or fix that issue, they had the idea of NoSQL, which is an ingenious naming scheme. It basically is the opposite of SQL. There is no table format like there was for SQL. Instead, there are different, whatever the programmer that made the software kind of wanted to use, they use that instead. The two most common you're going to ever see are one's like a tree structure and one's a document storage. So like a tree structure is like, it basically stores a gigantic JSON object, and you just kind of push and pull keys from the object to store data. And a document store is a little bit more complicated, but generally speaking, it's like you have a box full of documents, we'll call them, and each document is going to have different entries, like, whatever you want to store, for example. So a good example of this might be like a messaging app. You might have in your document storage database a document for each group chat the person's in. And each document will store, for example, the messages that have been sent, the timestamps, who's in the conversation, and stuff like that. And you can see that you can maybe work in a table, but it wouldn't really make sense to make it, table-like, because it makes kind of more flow sense to have it be this more document-style storage. And as a result of this more NoSQL, like less structured approach, NoSQL databases became very fast, very easy to scale in comparison to SQL, and very easy to develop for. Because what they end up doing, like data storage wise, is actually just JavaScript. If you think about it, right? JSON is JavaScript objects. So kind of interfacing with that from a web perspective is super, super simple compared to SQL. And so there are a bazillion different NoSQL databases you can probably use. The most common one you may have heard of is called MongoDB. That's used by a lot of companies right now. We're going to specifically focus on something called Firebase real-time database, which is extremely easy to use and actually free for basically small project, which is perfect for our situation. Whereas like Mongo or an AWS service would cost money, we don't have that available to us, unfortunately. So what is Firebase? Firebase is, again, just a prototyping application tool for Google, made by Google for any developer, really. It's kind of like AWS, if you ever heard of Amazon Web Services or AWS, but much, much cheaper, much more feature-rich and free for smaller developers, unlike AWS, for example. And there are, I think, like 10 or 15 different features available in Firebase or AWS, or both Firebase here, Firebase. However, we're going to focus solely on the real-time database, which is their NoSQL, one of their NoSQLs they offer for us to use. And it's very, very easy to use. Like, trust me, it's not hard. So real-time database stores stuff using a JSON tree structure, like we talked about earlier. So as a result, every data, all the data you want to store must be a key value pair, like it would be in a normal JavaScript object. And since JavaScript handles JSON really well, since that's what it's really meant to do, it can actually, communicate with this and handle the data from this with absolutely no issues. It's actually meant for this kind of application, actually. So we're going to go through setting up a basic real-time database and kind of mess around with it and see how it works. And after that, we'll go through actually how to use it in code. So this is more like a follow along kind of thing. So maybe you want to, try to follow along. If you just want to read instructions, there are slides here that are hidden from presenter mode that have all the pictures and steps you should follow. And on the GitHub in the demo1 folder, there's a document with all the steps in a more text format. So plenty of ways to figure out how to do this. But simply enough, you're going to do this. You're going to go to firebase.google.com. And you should see this beautiful splash page they have made. And if I just move this out of the way, in the very top right corner, you'll see a little blue Go to Console button. You're going to click on Go to Console. And you might have to go through some, accepting some terms and conditions if you don't have a Google account signed in already. But once you do, you should be at this nice dashboard which will, once you finish, show you all of your projects that you've been working on. As you can see, I would have a couple, but we'll make a new one. If you don't have any, that's fine. To make it, you click this very big and very prominent Add Project button. And from there, give it a name. So we'll name it, the naming is not super important, so we'll just call this like test database. The only requirements are it cannot be no spaces. It will just prefer you to put hyphens because again, URLs break with spaces. And the bottom, you see a little pencil icon, that's the actual name your database will have. Reason here being, I'm gonna guess there are other people who have named something called test database before. And so there's some random characters to make it unique for my application. Then we continue, and we're gonna go to this next step of 2. When it is disable analytics, you don't have to, but it's good to give them less data because Google's got too much already as it is. And then after that, you're gonna create your project. This may take a few minutes, so just kind of have to chill out and watch it, kind of spin around. But once it finishes, you will be taken to your configuration page. And that's kind of like the first of several key steps you got to watch out for in this process. So we'll just let it finish up. All right, cool, we're good to go. And once we're at this config page, we're going to go first to these real-time database. Oh, first of all, on the left here are all the things you can use with Firebase. As you can see, there are a lot. You can basically make a full-featured application hosting provider using Firebase. You have everything from database storage, to authentication, to actual document storage, to hosting, to crash reports, to feedback, everything you can actually think of to make an actual web app nowadays. But we're going to go to real-time database. There are 2, Firestore and real-time. There are different types of NoSQL. So real-time is again that tree structure based on object, whereas Firestore is like document storage. So if you want to try that other kind of document storage database, you can try using Firestore above. Now we're going to do that, hit create database, and then just choose whatever default they give you in the US. And the key step here, make sure you hit the start in test mode. This is important to note though, and we'll talk about this more in the slides. Test mode means that the database will be allow anyone to have complete write or read access to your data for 30 days. As you can imagine, this is a pretty dangerous thing to have on the web. So you should never, ever, ever actually publish a database that actually has test mode enabled for actual consumption. Once you want to actually deploy this into, say, like a real-time application for in a portfolio or whatever, what you should do is actually learn about how to do authentication and learn how to do Firebase rules, which will limit what people can do with the data and only allow them to access, whatever they're allowed to access, for example. Once you have that, you'll see your database here. It'll be blank. That's okay, no issues. But you're gonna, after that, is everyone first of all at this step? Yeah, cool. Once you have that, go up to this gear icon in the top left next to your project overview and go to project settings. We now have to actually add an app to our Firebase project. So scroll down, we'll go to your apps and select the little HTML code looking icon, aka the web icon. You can nickname your project whatever you want. I'm going to call this in-class demo and hit register app and give it a second to just go through, and you're going to see a bunch of code right here. Don't worry too much about this. We'll kind of walk through what it means in more detail, but the key you have to know is copy this Firebase config object right in the middle there. So the API key down to the app ID. You're going to copy that and then go to continue to console. And that will enable any web app with your login details within the API information to access your database. Now, this is important is keep an eye on who has access to your API details. That's obviously a good thing to keep private or keep limited in access. However, because it's a website, everyone will have access to your database credentials. It's not a super big issue. They kind of know that already. But it is good to keep that at least somewhat protected, basically. Now, once you have that, you are good to go, and your database is 100% configured for Firebase. And again, note with security, please, please, please do not publish your database on the web in test mode. That because what it means is anyone can access the entire database for 30 days. This is a very bad security risk and it's actually a horrible idea. If you intend to actually use this for a demo or a portfolio or just show to a friend or make it an actual commercial service, learn about how to actually authenticate users and limit what parts they can access depending upon the authentication level. If you want more information, the Firebase SDK or API reference is very, very good and gives you more than you could ever possibly really care about to learn how to actually use Firebase properly for every part of it. All right, is everyone so far doing okay? And Wallace, what about you online? You doing okay there too? I think it's online, right? Yeah, it is. You actually only just got to the create part. Okay. Yeah, if you need a little bit more help with that, the slides have the picture steps and the actual GitHub has the written steps as well. So you can kind of follow both depending upon which you prefer. In the meantime, we'll go ahead and Wallace, if you need some more time to help figure it out, let me know. I can work with you the next checkpoint. Oh, there we go. Okay, so Firebase and Google, or Firebase and JavaScript, sorry. Now, we have to take a couple tangents during this section, but just can't stay with me. It kind of all comes back together again. But essentially, we'll be using NPM. And as a result, all of the Firebase functions must be imported from the appropriate what's called namespace. And if you've ever taken like C++ before, or know kind of like C++, you might be familiar with the idea of namespaces. If not, don't worry, they're not a very hard concept to figure out. But basically, there are going to be two important ones, Firebase/app and Firebase/database. So Firebase/app has all of the core setup functions. You'll only ever need it once and then you're done. However, Firebase/database has actually all of the like the read code, the read functions, the write functions, the more database appropriate ones. Reason for this is, again, there's so much to do in Firebase. It's better to make sure you only import what you need from the actual code that Firebase gives you, their SDK it's called. And so first of two tangents, or I guess three tangents here. One is about JavaScript import exports. So if you kind of recall a little bit back to our last couple of weeks about single file components, we did that whole export default and then the object, right? The script tag. And of course, don't worry about it. It's just how it is. Well, a bit more detail is each file in JavaScript, in NPM specifically, is called a module, basically. And it's kind of like a class, but the only catch here being in a class, in a module, everything is private by default. Everything, unlike in say, like Java or C++, where things tend to be public by default. So we have to use the word export to expose it to the public world or the other files in our project. However, there are two kinds of exports. There are named exports and then default exports. So the named export is the export with the two databases you see here. You might have used that with the database thing I talked about last week. If not, don't worry about that. But basically allows you to export actual things from your code, like variables, functions, objects, what have you. With the catch being, you must import them exactly as how they are named in the actual CRUD databases. Hence, named exports. They are named the exact same across files. On the flip side, export default will export a single item, with the catch being the export can be named whatever you possibly could want it to be. And the name's not super important. So why would you do this? Well, the catch here is, again, namespaces. Really, and you'll learn this very quickly if you've ever looked at your package.lock file, your node modules folder, but NPM projects get pretty big. And there can be a lot of other libraries doing a lot of different things in your code. And sometimes, and very often they do, will have methods or variables or something with the same name. And that can cause a clash or an issue with the JavaScript, because then you won't know which method to call for, say, foo or whatever you want to say. As a result, you can use named and default exports to make sure that you don't have any of these like import conflicts and that things kind of stay relatively namespace separate. However, in this class, because we're taking a pretty simple approach to how to make a web app, if you can always use a named export unless you have to use a default export. For example, Vue requires all SFCs to be default exports. So in that case, you might use a default export. But for the database stuff today, maybe use named exports. And then side tangent number 2/3, asynchronous methods. So a very powerful part of JavaScript is that the fact that functions and methods you create can be either synchronous or asynchronous. Synchronous functions act just like they do in normal programming, where they will stop the entire program for your function call to finish, and then continue from where you left off. On the other hand, async or asynchronous functions allow the program to continue working on other code in the background while the function runs in a different thread, for example. This is super useful for something like a database query, where if you have a big database query, if you do a synchronous call, what can happen is if the code hits that query and stops, it'll seize up the entire program, meaning your UI might not load properly, or your buttons won't work, or the user page might even freeze up. And that's bad for user experience. So you always put network operations, or like, for example, API calls or database queries or whatever you want to make into an asynchronous function, because we have no idea, first of all, if they'll succeed, and second, how long they'll take to work on our network bandwidth. And then there are two things you can choose. With an async function, you can either choose to continue and then come back after the function completes, or wait for the function to finish before moving on. There are pros and cons to each. However, in this class, we're only going to focus on continuing to go forward and then coming back once you finish the async call. And so how do we actually handle these kind of, go forward and come back? Well, to kind of handle this in JavaScript, there are things called promises. And a promise is, just like the name suggests, a promise that this network call or this asynchronous function will either succeed or fail, and will tell you when that happens. As a result, every promise has both a callback on success and an error on whenever an error handler is called. And as you can take a guess, all Firebase operations that we're going to create from the Firebase SDK use promises, meaning we have to handle both the callback and the error handler. That makes sense? Cool. So how do you do a JavaScript promise? Very simple. First thing you do is when you call the function like you will any other normal function, pass in your parameters the way you would pass in any other parameters, with the only catch now being you have to add, so this function will immediately return and give you a promise object. Now, you can technically store that object somewhere else, but it's not a good idea. What you should instead do is immediately after you do that, do these two things. So again, kind of think of this entire top line as a variable of some sort, and then we're calling a function on that variable, for example. .then is going to be your callback. So .then is just going to be the name of a function you're going to call when you finish, and then .catch is going to be the name of the error handler you want when you want to actually run if something goes wrong, for example. Now, this syntax probably looks a little bit different or very weird. And this is because, for simplicity's sake, because it makes no sense to have an error handler or a success function be a separate function, we instead use lambda or arrow functions. If you've ever taken like Python or EC 20875, you might have heard of lambda, like talked about very briefly in class once. But if not, lambdas are basically anonymous functions, or like a one-time use function that is just useful for doing lots of code, but kind of like hiding it from the actual program. So in this example, this arrow function, this arrow here tells us that we're making a lambda or arrow function, and that, oh, that went the wrong way. This is going to be the parameter to our function, and this is going to be the code for our function. So most, if not all, promises will return a value. Not always, but oftentimes they will. And the value will be the result of the promise, whether the promise succeeded. If it succeeded, like what returned from the API or something like that. And then the code will be something you have to handle when that called back. And we'll have an example of this in the demo program, so don't worry about that too much. The catch here being, and this is very key, all of this code here in this little 3 dots is only run when either the promise fails or succeeds. So if you have some variables, for example, that are maybe defined up here, but have data assigned to them inside of here. Down here below the promise, there's no guarantee that the variables will have the data actually in them when you use them for, say, a comparison or a display or something. So your code has to be able to handle what happens if my variables don't have any value. In Vue, it's pretty simple because you can just give like a blank value and Vue will handle the render for you. But in other code, it might be a bit more complicated. And then error is the exact same way, just only for errors. An error here, the parameter error, will be the exact error message or error code returned by the API or database. All right, I hope that wasn't too complicated, but now we're going to go back to using Firebase and kind of come back from a detour. So adding Firebase to your Vue project is really simple. So like 2 or 3 steps. The first one is actually copying and saving that Firebase config we made in that first checkpoint/demo. And the second one is installing the Firebase SDK using npm. To do that in your terminal, in the same folder where you have your project, you're going to type npm install Firebase. If you are using the code we gave you from the demo of from the GitHub, the Firebase code is already saved on the npm lock files. So all you have to do is type npm install, and it'll install both Vue and Firebase for you. But if you had a fresh new blank project, you would type npm install Firebase in the project in the command line, and that will install all the Firebase dependencies automatically. And the last thing I have to do, I think the demo is coming up soon in a little bit, is this kind of mess. So this is all that this is actually code that Firebase kind of gives you already in the reference guide. But here's everything you have to do to make a Firebase app, and then connect the database using your app in JavaScript. So as you can see, we have some named imports, right? Because again, there are a lot of libraries that use very similar naming schemes. It can be easy to accidentally import the wrong one or have ones that clash. So here, we only import initialized app from the core Firebase library, and then we import get database from the Firebase database SDK. Then what you would do is you would paste your config, where that to-do says paste config here, and then you would call initialize app and pass in your Firebase config. And that will just talk to Firebase servers, make sure the keys match up, and if so, give you a reference to the app. If the app is good, you can then create a database using get database, and it'll return you a handle to the database. Now, to make your life a lot easier, what I recommend you do is you export this const database reference here. Again, named export because you want to make sure we don't have any database clashes. And you keep all this code in a file in the src database.js, meaning that you can have this code once and import it from anywhere, and you can use it. You can use Firebase in all of your code, in all of your Vue components, no matter where they might be. And this is all given to you in the demo code. If you want to copy that, don't have to remember this or anything like that. Okay, now the last, I think, little bit of lecture we're going to talk about here about how to use Firebase. It's a lot to get through, I know, today, so just kind of got to hang in with me today. Proper web development principles. Any good web app is going to have a set of interactions that the user can do to manipulate data somewhere else in a server, typically. Now, collectively, we call these actions CRUD, and your final will implement all 4 of these actions. So CRUD stands for create, read, update, and delete, meaning the user must be able to create and store data, read the available data, update existing data, and then delete existing data. And that kind of makes sense, right? You obviously want to be able to do all 4 of these anyways, but it's just kind of good to have them formalized, because sometimes it's kind of useful to help think about how can I make this particular action versus like, how can I just have all actions? It's easier for, kind of helping it encapsulate how you want to, program. And so performing CRUD actions in Firebase, aka doing Firebase data reads and writes, are a little bit tricky because of the way Firebase works, but I think we can all handle it here. Essentially, all data actions need a reference. If you think about it, if you have a huge object tree of some sort, Firebase has no idea where to read from, where to write to, what to upload, what to delete, right? Because it's kind of all over the place. So as a result, we make a reference and say, I want you to refer to this specific part of the data and do this particular change at that reference. And so the reference here is going to be each key, like the list of the tree, will be an entry in the reference path, which is a little confusing, but we'll get there. So think about it this way. If we actually do this example in the test database, it might be a little bit easier. All right, you can actually go to this little 3 dots here and click import JSON. And if you browse and navigate to the, if I can find where I stuck my thing, where did it go? Yeah, if you want to navigate to the GitHub files, there's a folder called data.json. I want to just, import that. And import. They'll preload your database with some stuff that you can actually play around with already. So you can see that we have 4 parent keys, we'll call them, at the root of the database, and each one has several child keys. This is going to be 1 key for each semester that we have at Southwest Saturdays here, and then each of the child keys are going to be a bit more about that semester. For example, last fall we were over WebEx, we were online because of COVID. We were teaching React, and our final was a Pokedex app. And so each of these semesters is going to have that data for that specific semester. So if you think about it, slash rather, is refers to the root of the entire database. And then /fall is a reference to only the fall 2021 data and child keys. And then /fall final is going to be a reference to the fall 2019, so the fall 2021, sorry, and then the final, which is just going to be to-do app. And so you can reference keys by going down the list by going the key name, then slash, and the key name, and then slash, down until you get to where you want to refer or do your read, your write, whatever you might want to do from that point. It's important to note here too, that any reference you make will include the child data. So for example, if I just refer to slash, it'll refer to all 4 of these keys and their child keys. So it's always good to scope as high as you need to go, because you can always go down the chain later if you need to, for any reason. And to make a reference, all you got to do is import ref from database, because obviously it's a database function. And then you'll be calling the ref function with the database that we import from the database file you made earlier, and then the string path to that value. And that will return you a reference. So you can either store it in a variable or you can use it directly, your choice, but I tend to store mine because it's easier to see. And then now you can do multiple actions to your data. The first one is C, create data. That one is done by the set method in Firebase. So you import set, and then set takes 2 parameters. The first parameter is going to be the reference to where we should set the data at. And the second data is the actual data to store at that ref. So you can either store actual data or an object of other data. So if you think back to our first example, right, with the example database we gave you guys, if your reference was, say, fall 2021, you can store a object of the final location, the program, the topic, whatever. But if your reference was, say, final fall 2021 / final, that would be an actual value. Does that kind of make sense? Cool. Reading is a bit more tricky. Just read. So after you import and create your reference for whatever you want to go, you import the onValue method from the Firebase API. And the onValue is kind of like a mini promise, in that you have to provide the reference you want to do, and then a promise callback function that will run every time the data is updated. What that means is every time the database changes, either by your code or a different instance of your code, anytime at that reference you gave it, it'll send you the new data, basically, like a live update, which is pretty cool, right? And so as a result, we're going to give it a callback function. And then this function should do what you should actually do whatever you want. Maybe you print it out or put it in a list or display to the user or whatever you're doing with your data, basically. Writing is kind of or update is the the CRUD part we're talking about here, not just update, easy enough. You import update, you give it two parameters, the ref and the data to update. Important to note here, set and update sound similar, but they do two different things. Set will delete all the data at that ref and then add whatever you passed in at the second parameter, while update will keep everything unchanged and only modify or add keys to the data. Nothing will be removed from the database. So if you want to say update or write, do update. If you want to create, use set. And finally, D or delete. Easy enough, just import the remove function and you give it the ref you want to delete, and it'll destroy that data and any child data at that node as well. It's not called delete, by the way, in case you want to know, because delete is a reserved keyword in JavaScript. So the more you know. And then again, yeah, so again, be careful, set and update. Set will destroy everything at that ref and then store data. Whereas update will only update or add, nothing will be removed. So it's kind of a difference. So you can maybe see why you might want to use one over the other one. Okay, let's go to demo program number 2. So the demo, first I'm going to go to my database file and I'm going to paste the configuration I copied from Firebase's setup process. As you can see, it's nice right there. And we export database like this. And now we can now import the database from anywhere else in our JavaScript code, which is super useful. So the demo 2, which is just this component right here, has a very basic template string. Basically, we got 4 buttons, one for read, create, update, delete. Easy enough. And then what we do is in the script section, we have a handler for all of those different functions. We first import database from our database file, so we have to know what we're performing on. And second is we have to import the appropriate functions from the database, the Firebase database SDK. So for example, we have to import set, update, on value, remove, and ref. Now, you don't have to import all 4, only import what you need. But in this example, because I'm doing all 4, I will have to import all 4. For your final, for example, you may do your update or your sets like a different page. So you only import set on that view, and maybe in one you only do maybe you only remove it on a certain page. You have a different component view that has only imports ref or remove or something like that. So again, always import only what you need and nothing more. Makes it a lot easier. So let's go through a couple of methods here. First is create, or no, the first C, or first letter in CRUD is C. And so we have some data, just a key and some other key, easy enough. And what we do is make a ref. So we're making a reference using the database we've referred to, and then the key path will be added. If you recall, that path does not exist in our database at the moment because we're about to create it right now. We then do set the reference, comma, the data. And then look here, here's that gigantic callback we had before. So we have our then and our catch. Because again, set is an asynchronous function, meaning it will call the callback when it's done, and it will call the error handler if it goes wrong. Now, we should be good and nothing will ever go wrong, but in case it does, have some code to handle that too, which oftentimes you don't have that sometimes. So in our callback is very simple. I'm going to print out that it was successful. And if it does go wrong, I'll print out that we failed in the error message that Firebase returns from its query. Does everyone kind of see how we do promises here? Cool. We'll skip read, we'll come back to read. Here's update. So here data only has other key. There's no key in this updated data. And so when we do update versus set, that means that the value of key that was there before, I'm gonna make that bigger maybe. No, it's a little too big. There we go. Easy to see. Cool. That means that the value of key that was there before will be unchanged, whereas the other key will be modified to this new value. And so if we use set, it would actually remove key and only have other key once you finished it. Again, a basic, then catch this, print out we succeeded. And then delete, we are deleting the added, the thing I added. Again, our callbacks for succeed and fail. Now, reading data is a bit trickier. So we have a reference like we had before, and then we say on value data ref, and then this is kind of that callback mess I was talking about earlier. So snap is the name they use in the reference. That's kind of what I use here in my code, but it's short for snapshot because the data you get back during this callback is a snapshot of the data at the ref at the time it was modified. And so this here is a very complicated double for loop to iterate through every key in the database that we get back. Because if you remember, the database is just a structure of keys, right? And so we're just going through it key by key by key. And so you don't probably have to ever do this, but in case you want to know how to do it, it's right over there. And this will print out basically the key and then every subkey along that key. And now if we should go to our code and lesson 8 and pull up our browser console, I'm going to actually stick it on the side. Nope, there we go. All right, we go to console, we can see the output of our right there. We're gonna first read. And you can see we have now read all the database, all the data that was stored at that database at the reference, it's the blank reference, basically. Now if we create it and we look here, we now see that we have the callback was called a second time. You think about that, right? It was called the first time when we hit read, the second time because we modified the ref, which has been the slash, the whole database. And it's kind of hard to tell, but you can see this is all the new stuff. We have key, which is added properly in there, the on all the thing before. Now if we update, it's a bit easier to see. The stuff in between the 4 dashes is the new data. We can see that the value of key changed from what it was before, which was, so it's the tricky part. Your console will change it automatically for you. So you have to keep an eye out. But if you refresh for the actual way, you can see that had new value here now. You see that? We modify it to the new value. Whereas if we create it, we now are at other value. We update, we're back at new value. And finally delete, the data is gone. Meaning if we refresh the page, don't want to do that. We refresh the page and then read again, there's no more added key in the database. So does everyone see how we can use this code to make those changes to the database? Yes? And actually a cool part of Firebase is, say if we hit the word create and we hop over to a tab, it'll actually highlight in green and what was added, and in orange was modified and red is delete. So if we say we go back a tab to update, and when we go here, we can see it's yellow because we updated that data. And then if we go to delete, it's red because it's gone now. So you can actually see the data being modified in real time on this console page. So you can make sure that's actually working if you want to double check. All right, we're almost there. 4 more slides. Vue has something called, now, how do we load data with Vue properly? I had a button before, right? But obviously, if you're like a user, you don't want to have to hit a button to make it do it. So how can we trigger the load automatically? And for that, we can use mounted. So Vue has a mounted function that will only run when the page is fully loaded. It's kind of like a normal function in the methods part, but it's only run once per page load and then never again. So as a result, we put the database read here, because then we can guarantee that the page is fully loaded, the user wants to see the data, and now we actually have all the data we want to maybe fix after the fact, fully loaded for our modification after the fact. So in your Vue SFC, it'll be this. You'll have your normal fields you had before, and then there'll be a new mounted function right below all of that stuff. And in those P dots, you will put the actual database code you want to use to change the read the database. And finally, unloading. This is tricky. We didn't do this in our demo 2 program, unfortunately. But because we have a listener or an observer attached to the on value in the callback function, we have to deactivate that function. Because otherwise, there could be a possibility where we have some data corruption, data loss, which is always really bad. And so we have to deactivate the callback before we leave the page. And funny enough, Vue has a before destroy function that will run right before we unload the component. So put your code right there for that. And again, like that, you just literally just do before destroy. There actually are, I believe, 7 or 8 different lifestyle function, life cycle hooks you can use, like mounted, update, before mounted, destroyed, stuff like that. The 2 most common ones are mounted and before destroy. So let's just quickly look at those before we jump into a checkpoint for today. I'm just going to first comment out demo number 2 and uncomment demo number 3. And then same here and same here. All right, now let's scroll down and we're going to go to the demo3.vue. Oh, here. So this one actually will have, the template will be very basic, it's some quick text. All the fun stuff is going to happen inside the actual code. So you can see we're only in this one importing a few functions. Ref, we have to import ref, on value, and off. And so we scroll down, we now have a very simple two things, mounted and on before destroy. So mounted, if we can hover there, is kind of like that read function we had in demo number 2. The only difference here being it's going to be run automatically for us, meaning whenever the user loads this page, it will automatically load the data using the on value function. And then on before destroy, we will again make a reference to the data, then call off to destroy the data from the database, or not destroy, but destroy the listener for that data. And again, this is not super duper required. It'll function fine if you don't put the off or on before destroy. However, there is a chance that the code is in a cache somewhere that's not properly flushed, meaning you can lose a write or a read that you thought was saved, but wasn't actually saved. And so if you look at our browser console, oh my goodness, there we go. And we quickly refresh the page, you can see that we load all the data right there. And if we hide it, we call the remove listener function. And if we reload it, it comes back. So whenever the component is either removed, added to the page, the callback mounted is called, and then before destroy will be called before it's removed. So think about, if you think to your multiple pages, right, in your web app that you guys made last week, or you're going to make your final, you can use mounted and on destroy to, or before destroy, sorry, to make sure that things are only loaded when they have to be or unloaded when they're not. With that, we're done for today. So before we jump into it, feedback form, thank you very much for filling it out. And obviously, again, review hours are coming up Wednesdays at 6 p.m. to 7 p.m. Please come. And before we go to our checkpoint, I want to go through the final project with you all. I'm going to publish this that's the wrong one. Here we go. I'm going to publish this document on Slack and to your emails probably later today, tomorrow morning, hopefully. So you'll have it there as well. And we'll talk about it in more detail next week during our project workday. But basically, we're going to have a final product. It'll be due Saturday, November 13th. I was kind of wrong, my bad. And it'll be due at before midnight. But if you need more time, email us. I will 100% give you another week to work on it if you need. So again, I want everyone to basically kind of figure this out. And then here is the beginner one. So the intermediate demo, if you guys remember that at all from last week, or maybe it was like 2 weeks ago, I forget now at this point, you have your edit and your new. Your edit is a new view. You go back, and then your add a new view as well. And if you see edit this one, we actually edit this, and if we put some drunk there, it'll save those changes into a database, which what you'll look like, and you can see the changes effective in real time right here. Now, your more specific requirements are going to be, first of all, yeah, I have a reference to basically everything here. The recording for the past 5 weeks, right there, the official docs for Vue, ViewWriter, and Firebase, and your actual requirements are right here. Kind of lengthy, but not too bad. Now, obviously, Vue directives, you have one of each Vue directive, please, and at least one SFC, probably more, with both props, data, and a nested SFC or a child component, if you kind of think about that. Now, this can all be a single, this can all be the exact same for all I care, as long as you can show me you can use all three of those features. There must also be at least 3 methods somewhere in your program, and all the data must be stored in Firebase, meaning if I refresh the page, I should still see any changes I made to the database right there. My demo does not do that because, again, not safe, but yours should do that. And then you also must allow the user to do all 4 actions: create, remove, update, and delete. And then on the views, the actual router side, you must have at least 2 other views aside from the home view. And we must be able to navigate between the views. And we also must be able to pass data using props or something like that between the views, at least one view. And then finally, choose 3 of these little things here. So either 3 custom events, 2 computer properties, 3 CSS classes, or 1 slot tag. Your choice again, however you want to make it, okay with me. All right, so your checkpoint for today is going to be, this is not super important if you don't want to skip this one, but basically using Firebase. Basically display the contents of the example data they gave to you guys using a Vue components. And then add some boxes and text boxes to add or remove data to the database. And if you want an example of that, I have it on GitHub. It's in the checkpoint 2 files on how to do something like this, for example, but I can quickly walk you through it right now. So what I'm looking for is if we scroll up and I recomment this, and I uncomment this. Now, I would recommend you don't look at my code when doing this, try and make it yourself first. But if you are kind of stuck, by all means, please take a look. And if we go back and we just hide this, there you go. You can see we display all of the objects, right? This fancy little component, and we can add a new one, say fall 2019. The program was Android apps. The final was like a make a game. Fiction was like someone Armstrong, and school was still Purdue. And if we hit add, you can see it kind of pops up right there on our list of data. Does this make sense? I'm looking for today. Ish. That's okay. Cool. All right. So in that case, let's get in it. If you have questions, let me know, and we'll try to help you guys out.